Let's look at some strength of material in this next problem. We'll be dealing with area. You must be familiar with area, how to calculate area. You must know the area, how to calculate area. Area of anything, but here we are dealing with an area of something that's like this, of a rod. An area of a rod is it's like this square. If we have to calculate a rod, but if it has a hollow, it has an opening inside, or it's until to a certain point. It's like this. So the area for this one is this. The area for this one is this. So you have something like this. And the inner radius. So because we are not dealing with the hollow thing, so we have to remove this part. So to remove this part, you have to subtract the inner radius, this radius, and the outer radius, because you need this thing. This one, this one, this one, this one. So when a force acts on here, it doesn't act in the middle. So it will act to this position, like if it's like this, it will act here and then leave the middle part. In the middle it won't act. So if a force acts this direction, it acts this, not in the middle part. Here it acts everywhere because it does not have a hole. So when you calculate something like this and you have a hole, you have to calculate the area excluding the hole. So to do that, you have to subtract the outer diameter with the inner diameter. Then you'll get your error. And then calculating the stress. Stress is force over area. So we'll use this formula. So if something it is stress, let's say calculate stress, I'll calculate it like this. But if something let's say there are two forces acting on it, so like this, acting in different direction. This is the compression stress. So you calculate the stress with the two forces. So if you want, and the compression, if something it was like this, and I said you have to calculate the compression, or maybe it compresses and then it becomes smaller, like this, from this size to this size. I mean the length, not the thickness. It drops this thing. So because there are two forces acting in different direction, and then you know that you know that to shrink it, it has to be something like, yeah, it have to be something like this. You shrink, this is the shrink part, this is the normal length. So we are looking for this one, then we'll be given a modulus E. So you have to look for x. So the formula for modulus and stress, how does it look like? It is a stress. For this one, it's a stress over, this is a strain, equation of strain, this is a modular over, so even here it's like this. It's not, it's strain here. So equation of modular says stress over strain. So when you look for x and then there are two forces acting in different directions, that means you'll have two equations, because this one will make its own and the other one will have to make its own distance. So you'll have a strain here. So to calculate the strain, first of all, you'll calculate there what you have here. You have a modular, so first of all you can calculate this. Let's say this is 1, this is 2, and this is area 1, area 2, stress 1, stress 2, force 1, force 2. So we have to understand one things. Like, so when you calculate this part and then calculate the other part and then add them, the string, because the force act in the same, but they are same magnitude. So you'll have something like this, because the force are equal. You'll be having force acting that are equal. But to calculate the strain, first of all you have to calculate, let's say start afresh from here. Okay, let me redraw this thing. So it shrink to this. It's two. It is two way of other one they are not shrinking. The force is not shrinking. So here you'll be given this. This one is given, or maybe one of these. So if you find something like this, try to write something like this. And this one, so this thing is the same. The value of this one is the value of the material. This modulus, it's the value of a material, so it's the same thing. But and this one, yes, okay, this is the compression because it compresses. So there is the other one that is not compressive. It's tension. It's Trishna stress. Okay, so we are looking for x of this one and x of this one. So your equation will be, and then x is found in this equation. So you have x1, and then there's also for 2, and then you'll have half of this, half of this. So the total, they will ask you for the total, the next question. So I'm trying to summarize the next question. It will be simple. So you'll have something like this for this side, so even here is the same thing, just the direction of the force is different. So they can say the extension here here you'll be asked for the extension. The E is for a strain. The equation of a strain is like of okay, it's this is for the strain, so the strain is the same as well. The E are not the same. This is the E for the strain, this is for modulus. So you'll have something like this if there's expansion or anything again. So you must also know the and the size of the area where it's acting. Others have halos, others does not have. So when you calculate the area, they are not the same, the areas. If this side has a halo, so you have to calculate the area here is area 1. What is the same? The thing that is the same here, it's the modulus. So the force sometimes are not the same, but here mostly we apply the same and this. So this one it must not be the same. Sometimes it's happened that it's different, so you have to have the error of this one. So the error of the one must be different from can be different from the other one. So the extension, you have to use this equation. So how do you get this equation? So this equation, so the this total means we'll add the what do we have here first of all. So let's calculate this total. So it's the same as this. That means it's total. We can calculate this one first. 1 and 2. So because this so because here we have so we'll say stress, the stresses are not the same as it can change because the error differ. And then this is it. So okay, this one you can have it, this one you can have it. So you can find the total strain first, and like this can be the force that acted caused by the force that acted on this can be the force in the other direction. So this thing is the same. So when you have calculated this one, now you can go to your equation. Because you know the length of this bar, the initial length, not the final one. The initial length of the bar, you know this is the initial length. So when you calculate this, the new strain, you'll put your new strain here, and let's say it's 0,03. So you'll put your 0,03, and then your length, they can say it's 2 meter, and this is total, right? So you can put your 2 meter, then you find your total. So there are many ways to find this problem. It depends what do you know, what we understand it. So when they are talking about extension or compression, so you must think about the error. The error, is it correct? Is it how to calculate the error, how to find the stress? This thing is not that difficult. It's not if you understand that. Okay, the error of this one is this one. but we are looking for this area. So yes, you'll be given a diameter and the length of this one as well. This one, the length work with the strain most of the time. So if you are given a length, think about the strain. So this one it's a hollow one. Hollow. If it have a hollow, some of them can be extended to this one. So that means we'll have two different hollow if it cuts it to the middle. So the stress here and the stress this side, or the stress, yeah, the diameter, it can be equal, but the stress won't be equally, and the force distributed, it cannot be equally if this size are equals, if this it's equal to this size. So the force here and the force here can be equal, but the distribution of the stress here, it cannot, the distribution of the force can be different, because and the stress here and the stress here can be different, but the force can be the same. So when you calculate this, we must check the area, and then for this one, the extension, this is the simplification of the strain equation. So this can be E total, this can be E total, and E1 plus E2. So you can use the strain equation, find the strain first, if this one is confusing, because sometimes it's confusing. And then from here you can take your total ET. You know the equation, it's like this. And then if you find your T, you go back again to the equation of this, and then you can find your I. The totality is up to you how you do it, because here we can be given the force and the length. The length is for this, okay, and the area is for stress. So these two can, it's a stress, and then this one, it comes from there. They just made the subject of the formula the L. The L is the same. The L here is the same as the L here, but the area cannot be, sometimes cannot be the same, and the modulus is the same, as always the same. This thing is, these two always the same. The force, I'm not sure, but it does change. The force here and the force there, normally in this case, in this, we are dealing with the same force that acting on an object, but this one, it's always the same. And so this one changes because of the extension. This is the extension of the object if it experiences force, and the extension comes from the strain equation. So how extended, how depend on the so when you deal with question like this, you must bear in mind with the area. Be careful with the area, be careful with the stress is not the same, and the strain equation you must know. If you know the equation for this chapter, you can be covered. Let's look at some exercises. A metal below is loaded with 223 kilo Newton compressed load. Okay, so it's carrying load both sides, and the modulus is 80 gigapascals. So it experiences a force this direction and experiences a force this direction. So here there is this thing. So this one is just trying to draw this one up. This side is up. This one is the bottom part. Is this bottom part. So the area here is not the same. So the area here it's a full D, but the area here is D square minus D because it's hollow. There's a hollow, so the stress that acts this direction and the stress that acts this is not the same because the area is not the same. This is different area, and the area are different and they're not the same. So the force is the same, but the area is not the same, so the stress will be different. So the compression and everything, we'll check what is required to calculate. So they said calculate the stress in both the hollow and the solid section. So there's a stress on top, there's a stress underneath. So to calculate this one, you will have to the stress one, which is force over area. You can call it stress one. Which one is for the hollow or is for, it depends. So okay, it's up to you which one is F1. So you'll have to you'll calculate two, or so you'll calculate the area for the hollow and the area for the solid. Normally a solid, when talk about the solid, that means it's the diameter without the without anything. So it's only equation with one diameter, not the other one with the other diameter for the solid. So the other one you have a hollow. So first of all, we have to calculate the areas. So the area is there. Let's say it's a hollow area. So for a hollow, because it's a hollow, it's a hole inside. So I said, so we'll check the diameters. The diameter from the sketch. The side is 52. It's not clear. It's 52 here, and this one is 25. So this is the bigger diameter. It's the bigger diameter, which is 52. So this is, so you have two diameters. So this diameter is the same as this diameter because it's equal. So this is the outermost diameter, which is 52. So for 52, we'll say for the hollow, we'll say I'll put 52 converting the diameter to meters because it's in millimeters. We'll divide by 1000. So let me write it. So you'll have to divide the 50 by 1000, and then you'll have 0.05 meter, and you divide by 1000, and to the other diameter as well, it will be 25 divided by 1000. So we'll have something like 0.0. This is it's not 50, it's 52. So it's 52 from there. Okay, 52. So you said, but if you don't want to change it, means you can leave it like this, and then you don't change anything. So your stress will write it in megapascals. And so okay, to change it, but normally we used to change. So calculating something like this, there will be a lot of zeros. So I say shift pi multiply by let me say close bracket 0,052 square minus 0,025 square bracket equals 5313 to the power negative 137 times 10 to the power negative 3 meters as a square because it's area. So this is the area for the hollow, the area for the solid part. And so I have something like this. And then the outer day it was 52, so it's 0,052 square, and then calculating this one we'll say pi shift pi multiply by, it didn't divide by 4 this one. This one divided by 4. So dividing this one by 4, you'll have something like 53137 exp negative 3 divided by 4, and then it will be 1,632.8. So 1,632.8. This is 6. Also, this is the area. So for this one, this area will have to calculate it like just set pi multiply by 0,052 square divide by 4. Then this is the answer is 2 comma. The reason why it's big, it's because it's the area without the value, so it's nothing subtracted to it. So you'll have times 10 to the negative 3 meter. So you have areas now. We are looking for stresses. So the forces are the same. So which one is stress one? Again, let's say one. Let's say hollow. So the stress for a hollow is force over area. Hollow. So what is the force? Is 2, 2, 3 times 10 to the 3 divided by, this is the area, right? 1 comma 6 3 2 8. So from this point, you'll divide this two, you'll have this 2 is 2 2 3 exp 3 divided by 1 comma 6 3 2 8 exp negative 3. So it's 13657 75208 comma 2. So it's 136575208 comma 2. So it's Pascal. So to convert this one, say 1 2 3 4 5 6. So you'll have something like this. You'll have something like it's 52. 06. So this one is comma here. So converting to 3 decimal places. So we have this as a stress. So let's check another one for the stress of a solid. This one is solid. The stress of a solid so the stress of a solid, it's force over area. So the force is the one that does not change. Is 2 2 3 times 10 times 10 to the power 3. And the hollow, this is not a hollow, this is the solid. Solid is 2 comma 1 2 3 times 10 to the negative 3. Okay, it's 2 comma 1 2 3. Let's calculate. So it's 2 2 3 exp 3 divided by 2 comma 1 2 3 exp minus 3, and then what's the answer? It's 10 50 40 037. 10 50 40 037,7 Pascal. Converting this one to megapascal, you say 1 2 3 4 5 6. So this is megapascal. This one can convert. And this is the stress. Let's check another question. What does it say? So we have both stresses now. Does it calculate the change in length? The change in length is x. This x. When it's compressed. When the metal is compressed. Change in length is this x. So how do we calculate the change in length? So to calculate the change in length, you have the stresses, all of the stress. So first of all, you have to find this. And say number 2. Change in length. So it doesn't matter whether it's compression or tension, as long as you know how to find the stresses first, and then you can find the other side. So you'll have something like this for the hollow. This is the elasticity of modulus. And let's try to calculate it here. So you'll have something like comma 575. Okay, it's even if means is times 10 to the 6. So the modulus, it's what you call it, given as 80 gigapascals. So where is there? So let's say it's 80. Or should I shift it? You find the strain first. Okay, can you shift this side? This is 9, my 9 6. So you have something like this. The rest of it hollow. This is hollow. And so this you'll have something like 1. And then exp 6, so it's 6. Then divide by 80, comma, no, comma, exp 9. Then the answer is this one. You see, it's very small. It's 0 negative. It's 1,707 to the negative 3. So this one for the hollow, you found it. It's 1,707 times 10 to the. So there's no units for this one. So this one you find it for the hollow. Let's check for the solid. So we're dealing with this one now. So you'll have something like this for this is strength. So your strength is given, it's 1. It's not given, it's calculated. So times times 10 to the power 6, and then so calculating this, so we'll have something 105,04 exp6 divided by 80 exp9. It's 1,313 to the power. So you have this one for the solid. It's 1,313 times 10. So this is you find this, the solid and the hollow one. So from this position, because the length of a hollow and the length of the solid are different, so yeah, you have to calculate different length. You have here is 45, here it's 15 days, 45. So we'll go back to the equation, finding the x of a of a hollow, because they will compress differently. There will be different compressions. Reason being the area is not the same. The force that is applied to this is the same, but the pressure on around the area is not the same. So the compression will be different. can have more compression on the smaller area than on the bigger area. So like if you have something like this, still get one side. If you have something like this, which does not have a hollow, and then you sit on top of it, will stand for a long, and then it won't compress. But if you can take a box, let's say this one is a wood, and then let's check at the box. I want to do the practical stuff. The practical stuff help us to understand where a box. And stick it to box. You sit on top of, and you sit on top of the wood. Which one will compress more? And this one can compress at this length with slightly compression, but this one can go far, but it can even reach here. Like a paper, if you a box, anything like this one will compress much than this one, because this one is a solid, this one is what a hollow. So we'll have different lengths from here to here. So the normal length for this one, and okay, let me say this. Here is it here. We'll have the length for this one. I have the length. It will compress different. So yes. No space. So we're looking for L for this, for X for this one. So the one for highlights. The hollow is 1 comma 0. So calculating this one, you'll have 0.0256. We have something like this. And then let's check for so the length for this one is 45 multiplied by 313. So now you can add the hollow and the for the total. Yeah, so this is 0.2 0,256. This is for hollow. Comma 0,256 plus 0,059. And then adding them, comma 0,256 is 0,0846, let's say 7. The final answer is 0,0. And so you have something like this when you're done with the calculation of this. So this is how is the extension they are looking for. The extension is the change in length. This is the change in length, and that's it.